Hello, dear learners. A very good day to all of you. So, this is the second part of NPC lecture. So, this today's lecture will be dealing with the characteristics of normal probability curve, and it does have quite a few interesting characteristics. So, in this session, you'll be able to identify and describe what are the major characteristics of NPC, which includes its shape, its symmetry, and central tendency. Later, later on, you'll be also able to interpret the relationship between mean, standard deviation, and the area under the normal curve. So remember, in my earlier lecture, I talked about tally, right? And how through tallies we were able to calculate the frequency. And when we were able to do that, then only we were able to plot the frequency polygon. Now, if you compute this frequency polygon, then you will find out that the mean will be equal to the median, which will be equal to the mode. And if you calculate here, I think it will be approximately, it is around 52. So this bell-shaped curve is technically known as the normal probability curve. Now, this is how the shape will start coming. The more values you start to put, the more refinement it will come. The more your frequency polygon will become smooth. Here you can see the individual points, but the more their data set would be there, the more smooth your frequency it will become more in a bell-shaped form. So what is normal curve? Now, if you look at the whole concept of normal probability, the law of probability, it was discovered by a French mathematician, Abraham de Moivre. And it was way back in 18th century where he developed this mathematical equation and graphical representation also. And it was based on the law of chance or probable occurrence of a certain events. And when any body of observation conforms to this particular mathematical form, it can be represented in the bell-shaped curve with a definite characteristics. So what are the characteristics? It is symmetrical, it is bell-shaped, and it has two quantities, the mean, which is in the form of the peak, and S is the standard deviation, which shows the spread out, the tails, the girth of the bell curve. So why is it called normal? Because this is, you can say it comes from its widespread occurrence in natural and social science phenomena, a most important distribution in statistics, because many real world variables are approximately normally distributed, especially under the central limit theorem, which states that the sum or the average of many independent random variables tend towards a normal distribution. Now, this is the another, you can say the characteristic or another name for it is Gaussian curve, named after Carl Friedrich Gauss. He introduced the mathematical equation for the bell-shaped curve while studying errors in astronomical observation and measurement. So when he noticed these measurements were repeated many times, so most values they started getting clustered around the average and means with very few extremes on the either side, forming the symmetrical bell-shaped curve, and that's how this curve became to known as the Gaussian distribution in his honor. Okay. Now we'll be looking into the characteristic of the normal probability curve one by one. So the first characteristic, that normal curve will always be symmetrical. If you divide it right from the middle, it will be the left side will be the mirror image of the right side. You can easily fold it up into two halves and you can see that the left will overlap the right part. The normal curve is unimodal. What does unimodal means? The peaks occurs at the mean. There is only one peak or one maximum point in the curve. And the normal probability curve is unimodal because it has one mode. So the maximum ordinate occurs at the center. That means the maximum ordinate, which means the highest point of the peak of the curve will be located at its mean value. This will be exactly at the center. It will be not at the left side, not at the right side, but at the center. So in a normal distribution, mean, median, mode, they all coincide at the same central point. So this is the central position which represents the point of greatest frequency of probability. But as we move away from towards the center, from either side, the height of the ordinate starts to decrease. The curve gradually decreases and showing that the probability of extreme value is lower. Another characteristic is the normal curve is asymptotic to the x-axis. That means if you look at this curve, the bell-shaped curve never touches the x-axis. You can see here. It never touches the x-axis. So the curve continues to decrease in height on both the ends from the middle point, but it never touches the horizontal axis. Therefore, it extends from minus infinity to plus infinity. So it is asymptotic. So the height of the curve declines symmetrically. So if you look at the normal probability curve, meaning that the both side of the curve will decrease in an even manner, or it will be a mirror image of each other as we move away from the mean. So this property shows that the distribution of value is balanced. The number of distribution below the mean is also equal to the number above it, right? So the curve gradually slopes down from the peak at the mean towards the tail on both the side. Then the points of influx occurs at point plus minus 1 standard deviations. So this shows that if you see the point from which the direction changes from convex to concave, and if you mark it along this point, if you mark it along the x-axis, you will find that this is where the standard deviations, minus 1 standard deviation and plus minus. So these are the point of influx of the curve of the bell-shaped curve, in which the direction is changing from convex to concave. And as it touches at a distance at 1 standard deviation, you can see from the top, it will touch to the horizontal at 1 standard deviation. Now, the total percentage of the area of the normal curve within the 2 points of influxation is fixed. And we have seen that. Remember the empirical rule? We have seen that at minus 1 and plus 1, the percentage of the cases that would lie in this particular would be 68.26%, or in other words, 68% to round off. This means that nearly 2/3 of all your observation in the normally distributed data will lie within 1 standard deviation above and below the mean. Next, the next characteristic is the total area under the normal curve may also be considered 100% probability. So we have also seen how this again follows the empirical rule formula. 1 standard deviation, 68.26. The area under the second standard deviation, that is 95.44. Under third dimension is 99.73. So every observation or data will fall somewhere under this curve, whether near the mean or at the extreme tails if it's an outlier. Thus, the entire area signifies the totality of all the probabilities, while specific section under the curve represents the probability of a variable falling within a particular range. The normal curve is bilateral. Bilateral meaning that the 50% area of the curve lies at the left side of the maximum central ordinate and 50% of the area lies at the right side. Hence, the curve is bilateral, and you can easily fold it in the middle, and you can see it is the left is the mirror image of the right. Then the normal curve is a mathematical model in behavioral sciences, especially in mental measurement. Now, this curve is used as a measurement scale, and this measurement unit of the scale is plus minus 1 standard deviation. So the normal curves, which serves as a mathematical model in behavioral science and in mental measurement, it is because it is helping to describe and interpret how the whole psychological traits are working. For example, like intelligence, aptitude, or personality, how are they being distributed in a population? So it acts as a measurement scale when scores are compared to the mean, that is the average, and measured in units of standard deviations, which tells us basically how far a score lies from the average. So, for example, if the intelligence score, the mean IQ is 100, right? This is the mean. The mean IQ is 100. And the standard deviation is 15. So, if you want to estimate how many, through the empirical rule formula, how many people will be having IQ in the first standard deviation, right? So, first standard deviation meaning between 85 to 115. This will be the IQ score, which of plus minus 1 standard deviation, and which will be around, like I said, 68% of the people will be with this particular IQ score. Similarly, if you want to find out regarding the IQ score of second standard deviation, which is plus minus 2 standard deviation, so you can calculate it. It will come around 70, 130, right? So which is equal to 95% will be lying in this particular thing. And of course, for the third standard deviation, you calculate yourself and you'll find how many percent of people will be lying in uh, the lowest, that in the 99%, that is in your bell curve. Now, what is this actually helping us or helping the psychologist? Why are they finding through normal probability curve? Because through this, they can classify the intelligence level. For instance, they can also identify which learners are the gifted learners. That might be above plus 2 standard deviations, or they might be or below average, or you can say borderline mental retardedness can also be calculated through this. If they find out the IQ level which is below the average, or below um, by calculating below the standard on the left side of the normal probability curve. So you see, both the extreme ends can tell you the outliers which are also lying in the NPC curves, which helps the statisticians, which help the psychologists in order to map out and and study the variables under consideration through the normal probability curve. Now let's move forward. Now these are all the characteristics of the NPC. Now if we are moving forward to the interpretation of the normal probability curve, now we have to understand that if the frequency polygon of observation or measurement of a certain trait is a normal curve, so it is an indication of that the measured trait is normally distributed in the universe. Most of the cases, that is, the individuals are average in measured traits, and the percentage in our total population is about 68.26%. Approximately 15.87% of cases are high in trait measured. Similarly, 15.87% of cases are low in the trait that is being measured. And the test which is used to measure the trait is good. It also shows that, right? That is another, this is how we are interpreting through it. So the test which is used to measure the trait has good discriminatory value, or the discrimination power is good because it is differentiating between the poor, between the average, and also the high ability group. So that is the quality of a tool. If it is able to differentiate into different category, it can categorize into the learners into different categories, and you can differentiate one category from the another. So the item of the test used are fairly distributed in the terms of difficulty level. So through just by looking at an NPC, this is the interpretation that we can draw out. Now coming to the application part. What is the application of normal probability curve? The first application of the normal probability curve is to determine the percentage of cases in a normal distribution within a given limit or score. So just like I said in the earlier examples, I told you, if the mean was 70 and the standard deviation was 10, right? So we calculate, if you wanted to calculate in 68%, because that was where the first standard deviation of the learners were lying, the maximum amount of, the maximum learners were lying in this particular NPC curve, right? This is the level where it was lying. So in order to find out, so we saw the score as 60 and 80, right? So it determines that also. So the second application of NPC is to determine the percentage of cases that are above or below a given score or reference point. So here the NPC is also, you can find the proportion of the population scores below or above a specific point. So just in the earlier example, when I gave you the example of IQ as 100 and SD as 15, right? So through calculating the percentage, we can say, yes, 16% of the learners, they had IQ 115, or 2.5, they were learners which had above 130. They were highly gifted. So the percentage, you can also calculate the percentage of cases through NPC. Then the another application is to determine the limit of scores, which includes a given percentage of cases to determine the percentile rank of an individual or a student in his or her group. So by knowing the middle, that is how much the 50% of the students have scored this, the average, we can also find the score at the 25th percentile or at the 75th percentile, right? So roughly by calculating the Z score, we can able to do that. Here I won't be going in detail because the application part of the NPC, the practical application, or you can say the hands-on experience regarding the application of NPC part, will be dealt in the subsequent lectures after this lecture. So this is the only, I'm covering up the theoretical aspect. Then coming to the dividing the group into subgroup according to a certain ability or assigning the grades. That's another, you can say, the No, the another application is to find out the percentile value of an individual on the basis of the percentile rank. Once you know the rank, then you can easily calculate the percentile value of that individual. Then coming to the another application, that is how you're dividing the group into subgroups based on the certain categories or assigning them the grade. So, for example, you can say top 10% will be given grade A, right? Or the next 20% will be given grade B. So that's also, you can, NPC will also help you to divide the group based on the certain characteristic and assigning them the grade. And you can also assign the lowest grade, for example, to grade E and so on. Then to compare two distribution in terms of overlapping. So sometimes NPC also helps in calculating, or in we can visually also, it can illustrate, and if we can see more than two or more than three normal probability graphs can be compared, and in terms of overlapping we can see, and just by looking at the visuals we can understand what kind of trend is being followed, or what are the, how many outliers are there, or how is it negatively skewed or positively skewed. All that can be easily compared if we can have more than one NPC as well. Then to determine the relative difficulty of test items as well. So if the students, just like I said, if it is negatively skewed, that means that the test might be too easy, right? Or the items might be too easy to score, that is why it is negatively skewed. If it is positively skewed, that means just by looking at the graph, we can say, or looking at the NPC, the normal probability graph, we can say that most of them scored very low marks and the test was very difficult. So NPC basically helps the test developers to select a balanced type of test so that you get a normal probability curve and you get neither positively skewed or neither negatively skewed as well. So you can make reliable assessment by it. Now, coming to the conclusion. So, what have we seen in this session? So, we saw that NPC is a fundamental concept in statistics which represents a perfectly symmetrical bell-shaped distribution that illustrates how data are spread around the mean, right? And all its characteristics like right from the symmetrical to the unimodality to the fixed area proportion to the asymptotic nature, and which makes it a very powerful tool for understanding the variability in human behavior and measurement. So the NPC provides a standard for interpreting test scores, identifying averages and extremes, and also comparing data sets in education, in psychology, in marketing, in different fields. Thus, it serves a very, you can say, important and vital mathematical model for describing real world phenomena with precision and with consistency, right? So with this, these are the references that you can refer to and have a it is highly recommended that you read this book regarding NPC. And so the next subsequent lectures will be based on the practical application, in which you'll be having hands-on experience in all the points that I've just said about the application part of NPC. You will be having the a practical session and hands-on experience regarding that. So I come to the end of the session. I thank you all for your patience listening, and I wish you luck for the future and all your future endeavors. Till I meet you again, take care of yourself and have a nice day. Bye bye.